So our goal in this deep dive is to give you a clear shortcut, really, to understanding the complex, high-stakes world of AI-powered deepfake detection. We're going to pull key insights from a comprehensive study on the subject, focusing especially on how major social media platforms like Meta and X are trying to tackle this problem.
And the stakes really couldn't be higher,
Yeah.
Deepfakes pose these significant challenges to the very integrity of information we see online. It impacts everything from political discourse, elections, obviously, to personal security, even financial stability. Social media platforms in particular, they aren't just places to connect anymore. They've effectively become these massive battlegrounds for information warfare. Content spreads so rapidly to literally billions of users. So a single well-crafted deepfake can go viral within hours. And that causes widespread misinformation, significant disruption, often before anyone can even react properly.
Okay, let's unpack this a bit then. What exactly is a deepfake, fundamentally, and how does this technology actually work? It still sounds a bit like, I don't know, science fiction to me sometimes.
It does feel like that, but it's definitely clever AI, not magic. At its core, deepfake creation relies heavily on advanced AI, particularly a foundational technology called generative adversarial networks. You might hear them called GANs. So imagine you have two competing AIs, right? One is the generator, and its job is to create a fake image, say a face, that looks totally real. The other is the discriminator, and it's like an art critic, constantly trying to spot the fakes created by the generator.
Ah, okay. So they're working against each other.
Exactly. They learn from each other in this adversarial process. The generator gets better at fooling the discriminator, and the discriminator gets better at spotting fakes. This pushes the generator to produce more and more convincing fakes until it can consistently fool the critic. That's essentially how GANs operate, training each other to produce incredibly realistic synthetic content. And, beyond GANs, there are other powerful methods too, things like autoencoders, which can reconstruct and manipulate faces, or diffusion models, these are quite new, and generate stunningly realistic images by slowly refining random noise.
So it's definitely evolved beyond just, like, slapping one famous person's face onto another person's body in a video, right?
Yeah.
What are the different kinds of deepfakes we're actually seeing out there now?
Yeah, absolutely. While the classic face swap replacing one face with another is still pretty common, the landscape is much broader now and more nuanced. You also have face reenactment. This is where the original person's identity stays, but their expressions, their mouth movements, are manipulated. So they appear to say or do things they never actually did.
Like making a politician seem to say something controversial they never uttered.
Precisely. That's a key example. Then there's speech synthesis. This is about creating synthetic audio that perfectly mimics a specific person's voice. And often this is paired with the visual deepfakes to create really convincing audiovisual content. The voice matches the manipulated lips, and it gets even more advanced. We're seeing things like full-body puppetry, where entire body movements can be controlled, not just the face. And also attribute manipulation, which can subtly change specific facial features, maybe make someone look older or angrier or sadder than they actually were in the original footage.
Okay, here's where it gets really, really unsettling for me, the real-world impact of these creations. What are the main deepfake threats that social media platforms are constantly battling?
Well, the range of threats is incredibly diverse and, frankly, quite impactful. On the political front, deepfakes are a serious weapon. They can be used during elections to fabricate compromising statements from candidates, or maybe create false video evidence to sway public opinion.
Right.
We've definitely seen attempts to discredit figures this way.
Right.
Then you've got celebrity impersonation. This can be used to spread misinformation, damage reputations, or even create fraudulent endorsements. Imagine a fake video of a star endorsing a scam product. That can have real financial consequences for people who trust them.
Yeah, I could see that.
Financial fraud itself is a growing concern, too. We're hearing about deepfakes being used for things like fake CEO videos and business email compromise attacks, tricking employees into transferring money, or even creating entirely synthetic identities, fake people for large-scale fraud operations. Beyond that, deepfakes are increasingly just part of broader disinformation campaigns. They're designed to manipulate public opinion, sow discord, often by exploiting existing social divisions. And tragically, one of the most severe forms is harassment and abuse. This particularly targets women with non-consensual synthetic intimate content, often called revenge porn, which causes immense psychological and emotional harm. It's truly awful.
Mm-hmm. And what is it about social media specifically that makes it so vulnerable to all of this?
It really comes down to the inherent viral nature of these platforms. Their algorithms are often designed to prioritize content that generates high engagement likes, shares, comments. And deepfakes, because they can be shocking or sensational or controversial, they often trigger that high engagement, so they get algorithmically amplified.
So the system itself helps them spread faster.
In many cases, yes. Plus, you have the network effects. Content propagates incredibly quickly across interconnected platforms and communities. Containing it once it starts spreading is really difficult. And maybe most critically, there's this constant speed versus accuracy trade-off. The pressure to share breaking news or something that seems viral often outweighs careful verification. So deepfakes can spread really widely and cause damage before fact-checkers or even the platform's automated systems can catch up and respond.
So given how incredibly convincing these fakes can be and how fast they spread, how are platforms like Meta and X actually detecting them? It sounds like a nearly impossible task, honestly, with the sheer volume of stuff uploaded every second.
It truly is an enormous technical challenge, like trying to find this one perfectly crafted fake needle in a gigantic digital haystack. But AI is indeed fighting back. Modern detection systems mostly rely on deep learning. So essentially teaching AI to identify subtle artifacts, tiny inconsistencies in synthetic content that our human eyes would probably miss. Think of it like a digital forensics expert looking for microscopic clues. They use tools like convolutional neural networks, CNNs for short. These are really good at spotting almost imperceptible digital fingerprints or weird patterns in images and video frames that just don't look right.
Okay, so finding the tiny giveaway.
Exactly. And more advanced models, like transformer-based models, they don't just look at individual frames. They analyze how features change and interact across an entire video sequence. And often, platforms don't rely on just one method. They use what are called ensemble methods, basically combining multiple different detection models, each with its own strengths, to create a more robust and accurate overall system. More eyes on the problem, so to speak.
So it's not just looking at a single picture, but the whole video, how things move, how they connect over time. That adds another layer of complexity, doesn't it?
Absolutely. And that's where temporal analysis and video coherence come into play. These systems specifically look for inconsistencies across video frames that a deepfake algorithm might have missed. For example, they might look for subtle flickering that shouldn't be there, or unnatural blinking patterns. Maybe the person blinks too much, or not enough, or in a weird rhythm, or awkward morphing between facial expressions.
Things that just feel off.
Exactly. Often a way that's hard for a human to pinpoint, but an algorithm can measure. Techniques like optical flow analysis literally track the movement of pixels from one frame to the next. If someone's head moves perfectly smoothly but then suddenly seems to glitch or jump unnaturally, that's a big red flag. And then there are things like long short-term memory networks, or LSTMs. You can think of these like an AI that remembers how a real person normally blinks, speaks, and moves over time. So if a deepfake makes someone blink, say, twice as fast as normal, or stutter in a way that doesn't match their usual speech pattern, the LSTM flags that deviation immediately.
Got it. That makes sense. Looking for those behavioral inconsistencies.
And it goes even further with something called multimodal detection. This is really advanced stuff, where systems analyze multiple senses, multiple data streams, simultaneously. For instance, they'll compare the lip movements in the video with the corresponding audio track. Do they match up perfectly? Or are they slightly out of sync? Or they'll check if the facial expressions truly match the emotional content of what's being said. If someone is supposedly delivering an angry speech but their face looks completely blank or emotionless, that's suspicious. These multimodal systems process and correlate information from all these different inputs, visual, audio, maybe even text captions, identifying subtle inconsistencies that might be invisible if you only looked at one piece in isolation.
It sounds like they're looking for absolutely every single clue, no matter how small. What about, like, digital fingerprints left behind by the software itself that created the fake?
Precisely. Yeah, that's where forensic and metadata analysis comes in. This involves identifying those telltale signs, like specific compression artifacts, the way the video file is squashed down that might differ from how a normal camera or phone captures video, or inconsistencies in the EXIF data, that's the hidden metadata embedded in image and video files. Things like camera settings, timestamps, GPS location. If that data looks tampered with or doesn't make sense, it's a clue. Pixel-level forensics dives even deeper, looking for microscopic inconsistencies and pixel patterns that can reveal manipulation at a very fine level. And looking ahead, a really promising proactive defense strategy is digital watermarking. The idea is to embed imperceptible watermarks into authentic content right when it's created.
Ah, so you can prove it's real later on.
Exactly. Imagine content having its own invisible stamp of authenticity that detection systems can look for. That could be a game changer.
Okay, let's zoom in a bit on the major players then. Meta, Facebook, Instagram, and X, formerly Twitter. They're on the front lines of this fight every single day. How do they specifically handle this constantly evolving threat?
They certainly are. Meta, for instance, uses what they describe as a comprehensive approach. They have this multi-stage detection pipeline. It starts with initial screening, using lighter AI models for rapid processing of the sheer volume of content. Then, anything suspicious gets passed to more detailed analysis with heavier, more sophisticated models. And finally, there's often human expert review for the really borderline cases that need that nuanced human judgment. This whole system is continuously learning and updating based on new threats they see.
So it's layered.
Very layered. They also proactively scan uploaded content, trying to identify potential deepfakes before they even get widely distributed. When deepfakes are detected, Meta might remove the content entirely, especially if it violates policies on harm or manipulation, or they might add clear warning labels to inform users. And crucially, they've invested quite heavily in collaborating with third-party fact-checkers. They also played a big role in fostering better detection algorithms through initiatives like their Deepfake Detection Challenge, which really spurred research in the field.
Okay, and what about X? How does their approach compare?
X. They combine automated detection with a perhaps stronger emphasis on community-based verification. They rely on sophisticated machine learning classifiers that analyze visual content, metadata, and even user behavior patterns looking for anomalies. They have a very clear synthetic and manipulated media policy which outlines the rules against harmful or misleading doctored content. A really unique and, I think, powerful aspect of their approach is the community notes system. This allows users themselves to add context, clarifications, or corrections directly to potentially misleading content, including deepfakes, right there on the platform.
Crowdsourcing the fact-checking, in a way.
In a structured way, yes. And like Meta, they also apply warning labels to manipulated content. For suspected deepfakes, they might also use algorithmic de-amplification, basically, reducing its visibility in users' feeds to slow its spread.
It really does sound like this relentless game of cat and mouse, doesn't it? A constant escalation. What are the biggest technical challenges they face in just keeping up?
It absolutely is an arms race. And it's driven by several key factors. Firstly, the deepfake creators themselves are getting smarter. They're increasingly using what's called adversarial training. That means they are specifically designing their synthetic content to fool the known detection systems. They test their fakes against detectors and refine them until they pass. They're actively trying to trick the AI.
So the defense informs the attack.
Precisely. And at the same time, new and more sophisticated generative AI models are constantly emerging, often open source. This means detection systems have to continuously adapt just to keep pace with the creation tools. And then there are significant technical constraints. As we mentioned, social media platforms compress uploaded content to save space and bandwidth. But this compression unfortunately removes some of those subtle artifacts that detection systems often rely on.
Making their job harder.
Much harder. Scalability is another huge issue. Analyzing billions of photos and videos in real time or near real time requires absolutely immense computational power and resources. And then there's the delicate balance of managing false positives. You don't want your system to be so aggressive that it starts flagging legitimate content, think satire, parody, artistic works as harmful deepfakes. That raises serious censorship concerns.
Yeah, that's a tightrope walk.
It really is. And beyond these core challenges, new threats keep popping up, keeping the landscape dynamic. For example, low-quality deepfakes. You might think these crude fakes aren't a big deal, but they can still be surprisingly effective for spreading misinformation, especially among people who aren't super tech-savvy. And ironically, they might avoid detection because they don't have the sophisticated digital fingerprints that advanced AI looks for.
Simpler can be sneakier.
Sometimes. There's also the issue of partial manipulation. Instead of creating a whole fake video, attackers might just make subtle modifications to authentic media, changing a sign in the background, altering a document someone is holding. These small changes can be incredibly hard to detect automatically. And we're seeing more sophisticated cross-modal attacks that manipulate multiple things simultaneously, video and audio together, maybe combined with a coordinated social media campaign using bots. These are extremely difficult to counter effectively.
Wow. Okay, so beyond just the technology itself, this raises some really fundamental questions about society, doesn't it?
Yeah.
The implications feel vast. I mean, imagine a world where you genuinely can't trust anything you see or hear online.
That's really the core concern, isn't it? Firstly, there are significant privacy and surveillance concerns that come with detection. These systems often analyze biometric data, facial features, voice patterns. So it raises questions about how that sensitive data is collected, how it's stored, how it's used. And the potential for these advanced analysis systems to be repurposed for broader surveillance is something people worry about.
Right, the tech built to detect fakes could be used for other things.
Potentially. Then there's that delicate balance we touched on, censorship and free expression. Platforms have to navigate really carefully. They need to avoid suppressing legitimate content like satire, parody, art, or even genuine news reporting that might, for valid reasons, employ synthetic media techniques. This requires really clear, transparent guidelines and appeal processes.
Mm-hmm.
On a broader societal level, the sheer proliferation of convincing deepfakes, combined with the knowledge that detection systems exist, risks this general erosion of trust. People might start disbelieving all digital media, even authentic videos and photos. This really underlines a critical societal need for much better information literacy. We need to empower individuals, give them the skills to critically evaluate the media content they encounter, and understand that not everything they see or hear online is necessarily real.
We all need to be more skeptical.
A healthy skepticism, yes. And of course, the profound impact deepfakes can have on democratic processes, on public discourse. That's undeniable. We saw concerns raised during past election cycles, and there have been various international incidents where deepfakes played a role or were feared to have played a role.
So if we try to connect this to the bigger picture, where do we actually go from here? What does the future of this relentless fight against synthetic media look like?
Well, the future will undoubtedly involve a mix of things. New emerging technologies, yes, but also more proactive defense strategies. We're seeing exploration into areas like blockchain-based authentication. The idea there is to create these immutable, tamper-proof records of content provenance, basically, tracking where a piece of media came from, right from its source, to prove its authenticity.
Like a digital birth certificate for content.
Kind of, yeah. Hardware-based solutions are also being developed, maybe specific chips in phones or cameras that help with detection or authentication right at the point of capture. And further out, people are even exploring potential applications of quantum computing, both for generating even more sophisticated deepfakes and potentially for breaking current encryption or developing new detection methods, though that's still quite speculative.
Okay, so tech solutions are evolving. What about strategies?
Right, beyond just reactive detection, finding fakes after they're made proactive defense is vital. We talked about digital watermarking, embedding those imperceptible signals into authentic content. That's a key proactive strategy. Another area is behavioral analysis. Instead of just looking at individual fake videos, systems can analyze patterns of activity, how content is being shared, who is sharing it, are there coordinated networks involved? This can help identify large-scale disinformation campaigns that use deepfakes as one tool among many. But crucially, success in this whole fight really hinges on unprecedented collaboration. We need platforms, the tech industry, academic researchers, and governments all working together, sharing threat intelligence, developing common standards for detection and labeling, coordinating responses. No single entity can solve this alone. It has to be a collective effort.
So just to reiterate then, detecting deepfakes on social media platforms is truly one of the most significant technical challenges, but also social challenges of our time. It's this nonstop arms race, as you said, that demands sustained investment and continuous innovation.
Absolutely. And success in this domain, it isn't just about building fancier, more sophisticated technology. It also demands really thoughtful consideration of the ethical implications of user privacy and the broader societal impact. This fight is fundamentally crucial for maintaining public trust in the digital media we all rely on, for protecting democratic processes, and for preventing the very real widespread harm that the abuse of synthetic media can inflict.
So it leaves us with a thought, really. As deepfake technology continues to get better and easier to use, what responsibility do we as individual users have? How do we get better at critically evaluating the information we consume and share? And maybe, how can we each contribute, even in small ways, to a more resilient and trustworthy information ecosystem? Thank you for joining us on this deep dive into the world of deepfake detection. We hope you feel a little more well-informed and perhaps, a lot more vigilant about the digital landscape out there. Until next time.